All right, it's time to start going through the study guide for the Chapter 6 test. So just like the last test, this study guide basically has the same exact questions as you'll see on the test, just different numbers. So obviously the numbers that you'll see on your assignment are going to be different than mine. So if you have any questions, just make sure that you reach out to me. All right. So let's take a look at number one. A set of data is normally distributed with a mean of 60 and a standard deviation of 8. Convert 68 to a z-score. So just remember, when we're starting with the data item, our data item in this case is 68. We take that and we subtract the mean, and then we divide by the standard deviation. All right, so I'll just use the Desmos calculator here. So we're going to take 68 and we're going to subtract the mean. I'm going to subtract the mean. And then we're going to divide that by the standard deviation. Well, this turns out to be pretty easy because the z-score is just 1. And that is it. Type an integer and decimal. Do not round until the final answer. And that is it. Number 2, set of data items already distributed with a mean of 80 and a standard deviation of 4. Convert 83 to a z-score. So again, we're going to take the data item 83 and we're going to subtract the mean. So that's 3. And then we're going to divide that answer by the standard deviation, which is 4. So my z-score is 0.75. Okay. Number 3. The average score on the stats midterm was 80 points with a standard deviation of 6 points, and Gregor's z-score was 1. How many points did he score? So now we're going backwards. Okay, we're starting with a z-score of 1, and we want to figure out which data item will give us a z-score of 1. So going back to the PowerPoint, okay, if we're starting with the z-score, we do the opposite operations in the opposite order, in the reverse order. So we're going to multiply by the standard deviation and then add the mean. So we're going to take the z-score, which in this case was 1, and we're going to multiply that by the standard deviation, which was 6. So that's easy. And then we're going to take that answer and we're going to add the mean. In this case, the mean was 80. So that means that Gregor got an 86 on the test. Okay. So that is your answer for number 3. Okay. Number 4, a group of steers have a mean weight of 1,158 pounds with a standard deviation of 84 pounds. What's the actual weight of an animal whose z-score is 1.5? So same thing. We are going backwards. So we'll take the z-score, multiply by the standard deviation, and add the mean. Multiply by the standard deviation, add the mean. So the z-score was 1.5. Multiply by the standard deviation, which is 84. And then take that answer and add the mean of 1,158. Okay, so that data item is going to be 1,284 pounds. Okay. Okay, a town's January high temperatures average 39 degrees with a standard deviation of 11 degrees, while in July the mean high temperature is 72 degrees and the standard deviation is 10. In which month is it more unusual to have a day with a high temperature of 56 degrees? Okay. So when we want to figure out which one is more unusual, let's go back to this PowerPoint here. Okay. Okay. You might remember this example from the PowerPoint. Okay. We compare, in this case, we compare January and July by comparing their z-scores, and whichever z-score is farthest away from zero, that is going to be the one that's more unusual. So let's look at January first. So for January, we're going to find the z-score for January. Okay, our data item is 56 degrees. Okay, not 55, 56. All right. Let's see, the minus the mean. So the mean in January is 39. And then we take that and divide that by the standard deviation for January, which is 11. So we have a z-score in January of 1.5. Okay. And notice that's above average. So 1.5 standard deviations above the mean. Now we're going to do the same thing for July. So again, our data item is 56 degrees, but now we're going to subtract the mean for July. So the mean for July is 72 degrees. And we're going to take that and we're going to divide that by the standard deviation for July, which was 10, and we get negative 1.6. So January is 1.5 standard deviations above because it's positive, and July is 1.6 standard deviations below. So which one of these is farthest away from zero? Obviously, that's going to be the negative 1.6. So that was the one for July. So that means it's going to be more unusual in July. So the answer here is going to be A, and now we just have to fill in the blanks. It is more unusual to have a day with a high temperature of 56 degrees in July. A high temperature of 56 degrees in July is 1.6, okay? 1.6 standard deviations below the mean. Notice I did not type in negative 1.6 because the word below here implies that it's negative. So a high temperature of 56 degrees is in July is 1.6 standard deviations below the mean. Okay, and a high temperature of 56 degrees in January is only, okay, notice it says to round to 3, so it's going to be 1.545 standard deviations above the mean. Okay, so again, we found the z-score. Okay, the one for July was farthest away from zero, so therefore that is the one that's more unusual. Okay. Number 6. All right, so the mean weight of a breed of yearling cattle is 1,055 pounds. Suppose that weights of all animals can be described by a normal model with a standard deviation of 55 pounds. What weight would be considered unusually low for such an animal, and what weight would be considered rarely low? So this is similar to an example that you saw on your assignments. Let me bring this up here. So unusually low, to find unusually low, that means that we are more than 2 standard deviations below average. So unusual means more than 2 away. So that means our z-score has to be negative 2. That means we're going to find the data value that corresponds with a z-score of negative 2, which means we're going to do this right here. We're going to take the z-score of negative 2, we're going to multiply it by the standard deviation, and then we're going to add the mean. So multiply by the standard deviation and then add the mean. So take the z-score of negative 2, multiply it by the standard deviation, which in this case was 55, and then take that and add the mean. So that was 1,055. So that would mean a weight less than 945 pounds would be considered unusually low. Okay. To find the weight that is considered rarely low, we're going to literally do the exact same thing. Okay, let's go back to our example from the PowerPoint, but rarely low means more than 3 standard deviations below average. So we're going to literally do the same thing, except our z-score, instead of being -2, is going to be -3. So same thing we just did, but instead of using -2 as a z-score, we're going to use -3. So again, I'll take -3, I'll multiply it by the standard deviation of 55, and then take that answer and add the mean of 1,055. So we get a weight less than 890 pounds would be considered rarely low. And that is it for that one. Okay. So next question. Okay. A livestock company reports that the mean weight of a group of young steers is 1,079 pounds with a standard deviation of 86 pounds. Based on the normal model for the weights of steers, what percent of steers weigh? And there are 3 answers here. So remember, with this one, this goes to the second part of Chapter 6. We are using StatCrunch. We're using our normal calculator. Okay. So we go to stat, calculators, and normal. So remember with StatCrunch, okay, when you go on StatCrunch, statcrunch.com, you sign in with the same username and password that you use for, for Math Excel, and we go to open StatCrunch. Okay, and again, for normal distribution, we go to stat, calculators, and then normal. So again, that's stat, calculators, and normal. Okay, so let's put in our mean. Our mean was 1,079, and our standard deviation is 86. So based on the model, what percent of steers weigh over 900 pounds? So we're going to choose greater than because that is implied by over, and we want the percent that is over 900 pounds. And we have this answer here. So notice we want the answer as a percent, and they want us to round it to 1 decimal place. So this is going to be 98.1%. So 98.1%. Okay, now we want what percent of steers weigh below 1,050 pounds. So we're going to change, so same mean, same standard deviation, but we're going to change this to less than, and we're going to change that to 1,050. And we're going to compute, and we get this answer here. So if we convert that to a percent and round it to 1 decimal place, that's going to be what? 36.79. So that'll be 36.8%. Okay. Part C, what percent of steers weigh between 1,200 and 1,250 pounds? So remember with this one, we go up here and we click on between. Okay. Notice our mean and our standard deviation is the same, 1,079 and 86. And we want the percent that's between 1,200 and 1,250. And we're going to compute. All right, and again, if we round that to 1 decimal place, that's going to be 5.6%. And that is it for number 7. Okay. Number 8, the cholesterol levels of an adult can be described by a normal model with a mean of 181, standard deviation of 21. What percent of adults do you expect to have cholesterol levels over 190? Okay, so we have a different mean this time. So our mean now is 181. Our standard deviation is 21. And we're going to go back to this one here. We want what percent of adults do you expect to have cholesterol levels over 190? So we want this to be greater than, and we want it above 190. Okay. So notice, be careful. Notice this time it says to round to 2 decimal places. So we're going to convert it to a percentage and then round it to 2 decimal places. So that's going to be 33.41%. Okay. Part B, same mean, same standard deviation. What percent of adults do you expect to have cholesterol levels between, so we go here, between 150 and 170? Between 150 and 170. And again, we want it to be a percentage that we round to 2 decimal places. So that's going to be 23.03%, because that 5 makes it round up. So 23.03%, we expect to have cholesterol levels between 150 and 170. Okay, number 9, based on the model describing steer weights, what are the cutoff values for the highest 10%, the lowest 20%, and the middle 40%? So going back to our PowerPoint, right, this time we are going backwards. So when the percentage is stated in the problem, we enter the percentage as a decimal after the equal sign, and we leave the middle one blank. So what do I mean by that? So first of all, even though it doesn't expressly state it, this number here, the 1156, that is the mean. The second number, the 84, that is the standard deviation. So we put that in for mean and standard deviation. And we want the highest 10%. So, which means I want this to be greater than for highest. Okay. And I'm going to put 10% as a decimal. So 0.10 after the equal sign. So this is what I'm going to enter right here. Okay. Mean, standard deviation, make this greater than because it's highest. And I'm going to put the percentage after the equal sign. Okay. And this is your answer. It gives you the answer right here, round to 1 decimal place. So that's going to be 1,263.7 if we round that to 1 decimal place. Okay. So when I do the low for part B, when I do the lowest 20%, okay, I'm going to do the same thing, except I have the mean, standard deviation. I'm going to make this less than now because I want the lowest. And then after the equal sign, I'm going to put 0.20, so 20% as a decimal. So less than and 20%, and there's our answer here. So rounding to 1 decimal place would be 1,085.3 pounds. Part C, now we want the cutoff for the middle 40%. So now we're going to go to between. Okay. We have our same mean, we have our same standard deviation, and then again, once again, after the equal sign, I'm going to put 40%, so 0.40 as a decimal, and if I hit compute, it gives me the 2 answers. So it's going to be rounded to 1, it's going to be 1,112, and then the second one's going to be 1,200.0. And that is it for number 9. Okay, number 10, same thing, but different mean and different standard deviation. So, in what height interval should the company expect to find the middle 80% of kindergartners? So, our mean this time is going to be, let's see, our mean is 39.2, and our standard deviation is 1.9, and we want the middle 80%. So, I'm at between, and I put 80% after the equal sign as a decimal, and there's my answer. Okay, use ascending order round to 1 decimal place. So this would be 36.8, and then this one would be 41.6. Okay, so that would be the middle 80%. Okay. We'll go back to standard. Okay, at least how tall are the biggest 25% of kindergartners? So same mean, same standard deviation. We want the biggest 25%. So that means greater than here. And I'm going to put 25% as a decimal after the equal sign. So mean, standard deviation greater than 25%. And there's our answer. So 40.5, if we round it to 1, 40.5 inches tall. Okay. And that is it for the study guide. Make sure you reach out to me if you have any questions.